Alright, today we are starting 8.3, which is graphing rational functions. So now we've talked about rational functions, we've added, subtracted, multiplied, and divided rational functions, and now we're going to learn what it looks like to graph them and what the general shapes of some of these graphs are going to look like. So let's go ahead and take a look at some of these definitions. So first we want to know, we've talked about rational equations, some rational expressions, but now we're talking about rational functions. All that means is you have a polynomial involving x in the top and a polynomial involving x in the bottom. And the bottom cannot equal 0. Continuity implies that a graph can be traced with a pencil, never leaving the paper. So there are no breaks, there are no cuts, there is no stops in the graph on a given interval. An asymptote creates discontinuity. What it is it's a line that the graph cannot cross. So when you have an asymptote, it's saying that the graph can't go past this, and it controls how the graph will look. So we'll see what those look like as well. And then a point discontinuity. That's just where there's a little hole in the graph. So it stops for a real quick second, and then it keeps on moving. So we'll take a look at what those all look like as well. So vertical asymptote. If the rational expression of a function is written in the simplest form and the function is undefined for x equals a, then the line x equals a is a vertical asymptote. So for example, looking at x over x minus 3. If we look at this, we look at the denominator, and we know that denominators cannot equal 0. So all you're doing is setting the denominator equal to 0 and solving. So that's where I got that. We have x equals 3. That's where this came from, was setting the denominator equal to 0 and solving. So what that means is, when I come over to 3, a vertical asymptote is just going to be a dotted line going through x equals 3 that the graph cannot cross. So we have, so the graph may look, it's going to go down kind of like this. So it'll kind of like this, and then it'll go up this way. So it controls it because this is going to approach the graph, it's going to get close to the asymptote, but it will never touch it and it will never cross it. Point discontinuity. This one's a little different. If the original function is undefined for that similar thing, so if there's something in the denominator that is going to make that graph equal 0, then we look for that, and that's discontinuity. However, if we can factor it out of the numerator and cross it out, then it's only a point discontinuity. It's no longer an asymptote. So for instance, if you look at this, when I factor this, I can cancel x plus 2 and x plus 2. Because remember, this is like in parentheses. So I can factor those out, which means x plus 2 equals 0. X equals a negative 2. So at x equals negative 2, there's just going to be a little hole in the graph. So when I graph this, we're going to graph, so then we just graph what's left over, which is x minus 1. So we start at negative 1 and we go up 1 over 1. So I'm going that direction, but remember, when I get to negative 2 over here, where I'm down here at negative 3, there's a hole in the graph. So I'm going to draw the line down to it. Then that hole tells me, okay, there's a piece missing there because it's undefined at that point, but just that point, not an asymptote. Alright, so they want us just to determine the equations of any vertical asymptotes and the values of x for any holes in the graph. So what we want to do is the same thing we were doing in the last section, in the last couple of sections actually, with factoring. So we need to start by factoring everything first. So that's really the key to this chapter, is being able to factor everything first. So I can rewrite this as x plus 1 times x minus 1 all over. This piece is going to factor into x minus 5 and x minus 1. Notice, these x minus 1s will cancel. So when I set that equal to 0, we get x minus 1 equals 0, so x equals 1 is a whole. What's left down here that can't be factored out is x minus 5. So I set that piece equal to 0. Solve, we get x equals 5. That's a vertical asymptote. That's all you do. You factor it, cross out where you can. On the denominator, both pieces will get set equal to 0, but this one's only a whole because it was crossed out, where this one's a vertical asymptote because it could not be eliminated. So now let's jump into how do we actually graph these things. When we graph these, the first thing you need to determine is, are there any holes? Are there any vertical asymptotes? What am I looking at in terms of this graph? So first we look at this, we have x over x minus 2. So number 1, I'm just going to call it discontinuities. Sometimes that'll be holes. Sometimes that's going to be vertical asymptotes. I can't factor anything out here or cross anything out, so x minus 2 equals 0. So x equals 2 is going to be what? It's going to be a vertical asymptote. So I'm going to go right away to x equals 2, 1, 2, and we're going to put a dotted line going down this for my vertical asymptote, which means the graph cannot cross that line. So next, let's start by, so next we'll find a series of points. So we're going to go with a table of values. Now when you do this, you have to find tables of values. You have to find 3 points on one side and 3 points on the other side. Because if I find all my points over here, I don't know what's happening over here. There's still more graph over here. So we have to do at least 3 points on both sides. So when I pick my points, and remember we cannot pick 2. So I'm going to pick, we'll go -1, 0, and 1. And then I'm going to put a squiggly line here to determine that's where my asymptote is. And then we're going to jump over that and we'll go to 3, 4, and 5. So at -1, we have -1 over -1 minus 2. So that's going to be a -1 over -3, or just 1/3. So I have a -1 and a positive 1/3. Then we go with 0. 0 over -2 is just 0. So we have 0, 0. And then we go to 1. So 1 over 1 minus 2 is 1 over -1, which is -1. So notice we start to jump down here, because what this is doing is going to look something like that. Now, if you can't see that out of this, because I know what these are going to look like, if you can't get that, you've got to do more points. You've got to continue it out over here till you get the shape of the graph. Let's jump to the other side. 3 over 3 minus 2 is 3 over 1, which is just 3. So I have the point 3, 3. Then we have 4 over 4 minus 2. 4 over 2 is 2. So 4, 2. And then we have 5 over 5 minus 2, which is 5 over 3, which is 1 2/3. So we're up 1 2/3. And now this time my graph is going to look like this. This is a very typical shape of these graphs. They're going to have the two different curves going, one up and one down, almost kind of mirror imaging one another across a diagonal line there. So that's all there is to it. You first find the discontinuities. Is it holes? Is it a vertical asymptote? And then you look for a table of values. You find at least 3 points on both sides, for a total of 6 points. Alright, let's take a look at a different one. So we're still going to have discontinuities, and we're still going to have a table of values, so I'll leave those up there. Discontinuities. First off, can I factor this? I can. So x squared minus 9 factors into x minus 3 times x plus 3, all over x plus 3. So these cancel, and I'm just left with x minus 3. So under my discontinuities, we're going to say x plus 3 is equal to 0, so x equals a negative 3. Is it a whole or vertical asymptote? It canceled out, so this time it's just a whole. But I've got to figure out where that hole is. So in my function, we can say, okay, now let's find f of negative 3 then, and figure out where that hole is going to lie. So then we have negative 3 minus 3 is going to be negative 6. So at negative 3, negative 6, this is where my hole is going to be. So I put an open circle to represent the whole of that graph. And now we can just do, we know that our function here is x minus 3. I don't need to do a table of values because I just have a line. So I start at negative 3, and I'm going to go up 1 over 1, and then I can go down 1 over 1. And then we're also going to continue down this way. And that's our line. That's all is to it. So if you can factor things out and get it down just to a line, then it's normal. We don't have the curves in there if we can cancel things out. Alright, your homework for this, so that is the entire lesson. Your homework for this section is going to be on page 461, 13 through 25, all of the odd problems. So make sure you have all of your notes copied down before coming to class, please.